Today we're looking at the mid-segment of a triangle. This is a segment that joins the midpoints of two sides of the triangle, and every triangle, of course, has three mid-segments. We could connect M and P, both of those being midpoints, to get that mid-segment. M and N, again, N being the midpoint of this side to get that mid-segment, or of course the mid-segment PN. Because the definition is created by the midpoints, well, we know each side has been bisected by that midpoint. The mid-segment is always half the length of the side that does not have a mid-segment endpoint on it. So, right here, a mid-segment MN is always going to be half the length of BC. MP is going to be half the length of AC. That is part of the definition of a mid-segment. The mid-segment, the triangle mid-segment theorem, if we look at the mid-segment on a triangle, it says that the two sides of a triangle, the midpoint of two sides of a triangle is parallel to and half the length of the third side. So not only is MP half the length of AC, but MP will also be parallel to AC. And yes, I do have a mid-segment triangle right there on my arm, so it's good stuff. All right, in the diagram, DE is a mid-segment of ABC. Find the values of X and Y. Well, we know that XAC is going to be double DE. So that X would have to be 14. D would have to be a midpoint of that side, so 5 would have to be the same value of Y over here. And that is because DE was a mid-segment. It's created by the midpoints. Here we want to actually prove the mid-segment theorem. Well, let's just run through this real quick. If D is a midpoint of AB, E is the midpoint of AC, well, that means that the ratio here is 1 to 2. From that side to that side, from AE would have to be 1/2 of AC. And AD would have to be 1/2 of DB. And then that angle, that included angle right there, by the reflexive property, belongs to both triangles. And so this right here is showing these two triangles are similar. Okay? ADE, triangle ADE would have to be then similar to triangle ABC. By SAS, we've shown that two sides are corresponding and proportional, and the included angle is indeed congruent. So those two are similar by side, angle, side. So then we could say that these corresponding angles right there are, those are corresponding angles in the two triangles that are similar, so those must be congruent. Those two angles must be congruent. So what then can we say? We can say that those two lines are parallel by the converse of corresponding angles. How do we know that these two, that DE is half of BC? It's because those triangles are similar. And that is the similarity ratio. Because that's what we use. That's the same ratio we used to show that those were actually proportional. Those triangles were similar in the first place. So that's a quick proof. I didn't write it up formally, but I talked all the way through it and showed you what I would use for every step of the way. Now, the theorem 55.2 here, all right, if we're thinking about mid-segments and stuff like that, it says if a line is parallel to one side of a triangle and it contains the midpoint of another side, then it must also contain the midpoint of the other. So if we know that this line looks kind of like a mid-segment, we know it's parallel to the third side and one of its endpoints is a midpoint of the side, we're guaranteed that the other endpoint is a midpoint of the other side. So we can use that for all kinds of things here. Now here we want to identify midpoints and sides of a triangle. It says triangle MNP has vertices of -2, 4. N is at 6, 2. P here at 2, -1. QR, they tell us QR is a midsegment of M and P. Find the coordinates of Q and R. Well, if QR is a midsegment, then it's guaranteed that R and Q are midpoints. So the midpoint, of course, we can get by averaging the x's, 2 and 6. We add those together, we divide by 2. Our x coordinate would be 2. The average of 4 and 2 would be 3. So that point is 2, 3, and I think we can see right there in a coordinate plane that backs up our midpoint formula. Here the average of 2 and 6 is 4, which makes sense when we look at our coordinate plane, and the average of 1 and 2, -1 and 2 would be 1/2. So that one is 4, 1/2. All right, the mid-segment triangle created by all three mid-segments of a triangle. Now, this produces all of these triangles produced. 1, 2, 3, 4. All of them are similar to each other and similar to the greater triangle that they're a part of. That is because all these lines here are parallel, so they're creating corresponding angles that are congruent. We also know that those sides are proportional. They are half of the opposite side, and so on and so on. So here we want to show that STU is similar to PQR. Well, we're told this is a mid-segment triangle, so I know that TU is 1/2 of PQ. I know that SU is 1/2 of QR, and I know that ST is 1/2 of PR. So by SSS, they are all proportional, so they must be similar. We also want to find PQ. We want to find the length of this entire side over here. Well, first, I can find X. This side right here, SU has to be 1/2 of QR. QT has to be 1/2 of QR. So 19 must equal 2x plus 7. We can solve for x here, subtract 7. X would come out to be 6. Now we can plug it in over here for 4x minus 3. If we plug in 6, 4 times 6 is 24, minus 3, that comes out to be 21. And if this is 21, this side right here is also 21 because those are congruent. S is the midpoint. Comes together, PQ, the entire PQ would have to be 42 of whatever we're counting by, 42 units. A student determined that Toledo Street is the midsegment of the triangle formed by Columbus Avenue, Park Avenue, and William Street. Okay? The distance along Park Avenue between Columbus and William Street is 160 meters. You can see that marked there. The distance along Toledo Street is the same span. The distance along Toledo Street in the same span is 80 meters. Okay. Which makes sense. If that's a mid-segment, it needs to be 1/2 of that side. Find the distance from the corner of Columbus and William. Columbus and William. They're saying Toledo Street's right there. All right. I see what they're saying. All right, so the corner of Columbus and William to the corner of William and Toledo. Find that distance right there to the nearest meter. Yeah, I mean, we know that this is a mid-segment, and so that must be a midpoint. 1/2 of 240 must be 120 meters. I mean, what are we doing here?